Today, we're diving headfirst into the control room of the IP media world. We've got all these great standards for zipping video and audio around, but how do all those different boxes from all those different brands actually talk to each other? That's the big question. And today, we're unpacking the two big names in this space, AES70 and nmos.
Okay, so imagine this. You've just spent a fortune building out this beautiful, shiny new ST2110 facility. Everything's running over IP, the streams are flowing, it's great. But now, you need to connect your new camera to a switcher or route a mic to a console. How does your system even know that camera exists? And how do you tell it what to do? This, right here, is the control gap. And trust me, it's a huge deal.
So here's our game plan for this explainer. First, we're going to really define this IP control challenge. Then we'll look at the two very different solutions on the table, AES70, which is all about deep control, and nmos, the discovery APIs. We'll compare their whole way of thinking, and then, this is the important part, we'll look at the industry's official blueprint to see how it all really fits together. All right, let's start with the core of the problem, because getting those media packets from point A to point B, that's really just the beginning of the story.
Think of it like this. Standards like ST2110 and AES67, they're like the highway system. They give us all the rules for how the cars, our media packets, should travel, what the speed limit is, which lane to be in. But what they don't give you is the GPS to find your destination or the air traffic controller to manage all the routes. And that leaves this huge critical gap.
And this technology pyramid from the EBU, it just perfectly lays out the whole picture. You see, media transport, that green layer up top, that's our highway. That's just one piece of the puzzle. The real action for us today is happening down here in the yellow layer, operational control. That's where all the discovery and connection management is supposed to live. So the question is, how do we build that layer?
Okay, let's bring in our first contender, AES70. Its approach is to create a really powerful, super detailed language that lets you talk directly to the inner workings of any given device.
So the word to focus on here is comprehensive. AES70 is incredibly thorough. It uses what's called an object-oriented model. Basically, it sees a device as this collection of objects, things like faders, EQs, network ports, and each one has specific settings and functions that you can control with surgical precision. It's really designed to let you get your hands on almost any parameter inside the box. Now, you don't have to be a programmer to get what's going on here. This just shows you that structured approach. AES70 defines a basic building block or class, and then, to adapt it for something new like AES67, it creates a new, more specific version of that block. It's very formal, very structured, and extremely detailed. Think of it like having the full engineering schematics for a device's control system. And that detailed structure gives you a lot of flexibility. You could have one main controller talking to every single device. Or you could have one device act as a leader and tell other devices what to do. It can even play nice with other protocols. But you see the common thread here, right? The focus is always on commands being sent to and from specific devices. Okay, now let's completely switch gears and look at the other approach. If AES70 is the detailed language for talking to a device, nmos is more like the system's phone book for finding devices and the switchboard for connecting them. You see, nmos isn't one single thing, it's a whole suite of tools. But the two big ones you need to know are AES04 and AES05. AES04 is the discovery part, the phone book. A device pops up on the network and basically shouts, "Hey everyone, I'm a camera, and here are the video streams I can send." Then there's AES05. That's your switchboard operator. A controller uses it to say, "Okay, camera 1, I need you to send your stream over to switcher input 3 right now." And the philosophy here could not be more different from AES70. nmos is built using the exact same technologies that run the modern web. We're talking about simple, lightweight APIs, the same kind your phone uses to fetch weather data from a server. The whole design is about one thing, making it dead simple for devices from any manufacturer to get along and work together. And this diagram just says it all. The nmos model is beautifully, intentionally simple. You have senders and you have receivers. The whole job of the system is just to connect them. It intentionally ignores all the deep, device-specific details and instead gives you this universal, high-level map of the entire system. So let's put these two side by side, because we're not just comparing a list of features here. We're really comparing two fundamentally different ways of thinking about how to solve this problem. This table really breaks it down. AES70 uses that formal, heavy-duty protocol to get deep control inside a device. nmos, on the other hand, uses lightweight web APIs to manage discovery and connection between devices. It's like the difference between a scalpel, designed for incredible precision on one patient, and a universal handshake, designed so that absolutely everyone in the room can introduce themselves.
And hey, you don't have to take my word for it. This quote from MWA, one of the groups behind MAMOS, is so revealing. They say that trying to bundle everything into one giant do-it-all specification, what they call monolithic, is an anti-pattern in modern software. Why? Because it just creates problems down the line. Instead, they believe in breaking the problem up into smaller, focused, manageable pieces. So, we've got these two different philosophies. Which one is the right one? Well, more importantly, which one does the industry actually recommend we use to build systems that work? For that, we have to look at a really important document, the JTNM TR101-1.
And the key thing to understand is who made this blueprint. This isn't just one group's opinion. The JTNM is made up of AMW, the EBU, SMP, TG, the Video Services Forum, basically all the major standards bodies and heavy hitters in our industry. They all got together to create a single unified set of rules for building IP facilities where gear from different vendors can actually work together. And remember our pyramid? Well, this TR1001 document, it provides the specific mandatory rules for that yellow operational control layer. It takes that abstract idea we saw before and turns it into a concrete set of instructions for every manufacturer to follow. And this right here, this is the punchline. In standards documents, the wording is incredibly precise. When a document says you shall do something, it's not a friendly suggestion. It is a mandatory requirement. And the industry's own blueprint says that all media devices shall use NMOS IS4 for discovery and shall use NMOS IS5 for connection. When it comes to these foundational, must-have jobs, AES70 isn't mentioned. So this really distills it all down to its essence. AES70 is a powerful, comprehensive control language for digging deep into one device's settings. But nmos? nmos has become the industry's standard connection handshake for making sure all the devices in the system can find each other and get connected in the first place. So the biggest takeaway from all of this is that a very clear consensus has emerged. If you are building a modern ST2110 facility today and you need gear from multiple vendors to work together, the industry's own roadmap points directly to the lightweight, easy-to-implement APIs of nmos for that essential discovery and connection. But that leaves us with one last, really interesting question for the future. As these systems get more and more complex, what happens next? Do we need both of these things, a universal handshake to get connected, and then a deeper language for control afterwards? Will these two different philosophies find a way to work together? Will one eventually absorb the other, or will they just keep competing? One thing's for sure, the story of the IP control plane is far from over.